Okay, now let's move on to 3.B, like terms. This is on page 32. Remember that like terms are terms whose literal components represent the same number regardless of the number used to replace the variables. So 3x, y, z, and negative 2 zyx are like terms because their variables are exactly the same. So if I used a 2 for the y, I'm sorry, the x, if I put in a 2 for the x, 3 for the y, and 4 for the z, then that would be 6 times 4, that's 24. And you see, if it's in a different order, it does not change it, right? So that's also 24. So these, therefore, are like terms. So we can add the coefficients of like terms, okay? Now, say this was xyz and this was x squared yz. These would not be like terms because they're not exactly the same. Okay, so let's look at example 3.3. Simplify like terms by adding, simplify by adding like terms. So 3xy minus 2x plus 4 minus 6yx plus 3x. Okay, so we have um, an x and a y right here, and we have an x and a y right here. So therefore, this term and this term are exactly alike. Then we have just an x here and an x here. So those two terms are alike. And then we have this 4 hanging out by itself. It does not have a variable. So we're going to add the like terms. So negative 6 plus a positive 3 is going to be a negative 3xy. And a negative 2x and a positive 3x is going to be just a positive x, because remember that we don't write the 1. It's understood in front of the variable. And then we're going to just add 4 to that. Now, there's nothing else to do with this because we don't have any variables to substitute. So this expression is just that's what the end of what we're doing. Okay, let's look at 3.4, simplifying by adding like terms. We have 3a to the negative 2 power b over c minus 4b over a squared c plus 7a minus to the negative 2 power c to the negative first power b minus 4ba squared, whoa, ba squared all over c. Okay, now you'll notice that there's variables in each of these, but what I want you to look at is the term. So this is a term, this is a term, this is a term, and this is a term. Okay, so these variables are in each term. So what we need to do is we need to put them all, we need to make them either all positive, all negative, all in the numerator, or all in the denominator, so we can see if the variables are the same. So I'm just going to put everything in the numerator. So 3a to the negative second, b, c to the negative first, 4b, a to the negative second, c to the negative first, and then 4b a squared c to the negative first. Okay, now we can see what is the same. We have a squared, b, and c to the negative first, a squared, b, c to the negative first, negative a squared, c to the negative first, positive b. And this one is not like the others because the a squared is not a negative, okay? So only these 3 first terms are the same. So we're just going to add the coefficients. So 7, 8, 9, 10 minus 4 is 6. So 6, and then I'm going to write them just write it uniformly as a to the negative 2 bc to the negative 1, and then minus 4a squared bc to the negative 1. Let's see if that's right. Should be. They have everything in all positive, so I'll just rearrange it so all the variables are positive. So that's 6b over a squared c minus 4a squared b over c to the first power. And that's the correct answer. Okay, go ahead and do your practice problems. Pause the video and I will do them as well so you can check your work.
Are you done?
No, I'm not quite done yet. Almost.
All right.
Okay. Okay. Hopefully That made sense, and if not, glad to help you with that in class or during math tutoring, Tuesday or Thursday. You can post a question on band or text me if you have any questions. And I will see you on Tuesday. The homework is all the questions in the problem set. Okay, thanks.